All right, so for gases, we're mostly going to focus on their physical properties, and these physical properties are approximately the same for every gas because every gas behaves approximately ideally, under quote unquote normal conditions. And we'll focus on that a little bit later on. So the four physical properties we're going to focus on are P, V, N, and T. P stands for pressure. V stands for volume. N stands for the amount or the number of moles of the gas that you have. And then T stands for temperature. And what we're looking for with gases is what happens when you change one variable but keep the others constant. So for example, what happens when you increase temperature? What happens to pressure if we keep N and V constant, right? So we're not changing the amount of gas, we're not changing the volume, we are just increasing the temperature. And if you think back to kinetic molecular theory, you should be able to reason out what's going to happen, right? At an increased temperature, the particles are going to move faster. If the particles are moved faster, then the collisions with the wall are going to produce more force. Since pressure is force over area, we would expect pressure to increase. And that is what happens. As you increase the temperature of the gas, the pressure happens, or the pressure increases because these collisions with the wall are more forceful. The particles are moving faster. And so what we can say is that temperature is proportional to volume. And that's what this little symbol right here means. These means that these two are proportional. What that means is that they do the same thing. When one increases, the other increases. When one decreases, the other decreases. And the kind of equation here is T1 over V1 is equal to T2 over V2. So if you had, temperatures and volumes, you could plug in sets of data for under one conditions and then find out sets of data for other conditions. What happens, and the same thing is same for volume and temperature. They're also proportional, assuming the others are kept constant. And that makes sense. If your pressure is kept constant, but your temperature is increasing, then those collisions are more forceful. So to decrease the amount of pressure to keep it the same, you need to increase the amount of area. Let's take a look at what happens when you increase volume. What happens to pressure if N and T are constant? Well, if we think about increasing the volume, that's basically more area. And so we're going to have our collisions occur less frequently. And so if we have less collisions, we would expect pressure to go down. So you can see now we don't have a proportionality. In fact, it's the opposite. They're inversely proportional. And so that's what this means. You see, V is proportional to 1 over P, or they're inversely proportional. They do the opposite of one another. As one goes up, the other goes down. As you increase volume, you decrease pressure. As you increase pressure, you decrease volume, or you increase volume. Again, this makes sense, right? If you have a small container, you're going to have a whole bunch of collisions with the walls. If you've got a big container, you're not going to have nearly as many collisions with the wall, and so you're going to feel less pressure. And same thing, if we increase N, what happens to the other variables? If we increase N, we have more stuff. We have more gas particles. And so we're going to have more collisions with the wall. So we're going to have more pressure, assuming other things are kept constant. Or if we want to keep pressure and temperature constant, then we need more volume. Or if we want to keep pressure and temperature constant, right? We're not going to increase either one of those. Then we need to decrease the amount of force in these collisions so we can decrease the amount of temperature. And I'll give you an equation shortly that'll summarize all of this and make it pretty simple to understand.